Hello, this is Jim McKeeth, and welcome to this webinar on getting the most out of Android with 10.3 Rio. I'm going to show you how to make Android work for you. Down at the bottom there you see a link to the slides, which will also eventually host the replay, and some code for you to download as well. As this is a webinar, your line is muted if you're listening to this live, but you can go ahead and ask questions with the Q&A panel there on the right, and we'll answer them at the end. If you are watching the replay, you're on YouTube right now, and there's the replay you're watching. Here's our agenda. Kind of want this to be a combination of what's new for Android in 10.3 Rio, as well as kind of a state of Android today from a developer's point of view. Also going to talk about a little about Raspberry Pi with Android Things and Android Pie, two different Pis there, Pi versus PIE, and a little bit about why Samsung matters and why you should care. First, let's talk about multi-device. Multi-device is the future. We've been saying this for a while, but the future is now. Actually, the future happened in 2017. Now we're, past the future. But 2013 is when iOS and Android both individually passed macOS. So there are more iOS devices and more Android devices individually than there were Mac devices, macOS computers. But now in 2017, Android passed Windows. So there were more Android devices in 2017 than there were Windows devices. That's a pretty big deal. You look back, when this graph started out here in 2009, it was almost 100%, 90 some odd percent, or maybe 80, 90 some odd percent Windows. And now Windows is still significant, but Android is ahead of Windows. So it's not going away, but you really need to think about multi-device, because your users are using Android devices, Windows devices, and maybe iOS or macOS devices and Linux devices to accomplish their daily tasks. Luckily, RAD Studio, Delphi, and C++ Builder make it easy to build multi-device applications. One project can target every platform. We do have FireMonkey, which is our graphical UI library for Android, iOS, macOS, and Windows. And if you use FMX Linux, you can use it to target Linux as well. We do have a Linux compiler, but the compiler does not include GUI widgets, FireMonkey widgets, but you can still target Linux and build GUIs if you want to, or just use FMX Linux if you want to be able to get FireMonkey on Linux. And then you can have one project for every platform. Really is beautiful because one of the things that's cool about it is you can do these variant layouts where you can design your UI once and you can say, oh, on Android, I want it to be slightly different. On a tablet, I want it to be this different this way. On this size phone, let's make a slight variation this way. So it makes you very productive to reach all these platforms. Let's talk about Android specifically, though. This was an advertising campaign that Android did a while back that I really liked. Be together, not the same. The idea is that there's a wide variety of Android devices, and you can find the Android device that expresses your individuality, and you can customize the Android device. I love that. I have a different launcher on my Android device, pretty much always have, and you can customize Android a lot. Very customizable. That's great as a consumer. Lots of choices. Unfortunately, as a developer, it means you have lots of devices to support. This is the top 20 Android manufacturers by market share. You can see 45% of all the Android devices are Samsung devices. Okay. The next three are from China, and then everybody else is really kind of a bit player at this point. So it really is quite interesting to see this, to realize how big of an impact Samsung has in Android. Most devices are Android. Here's the top Android devices worldwide, and then I just picked 4 countries that I thought would be interesting to look at. We see, again, I've highlighted the ones that aren't by Samsung. Most of them are Samsung devices. Even in China, the number 2 the first and second most popular devices are by Samsung. They have a lot more representation of other devices there, Chinese devices, and then Brazil, we see, has about half and half. Well, the first 5 are Samsung, and then the second 5 are non-Samsung, and then beyond there, who knows. But I just want to give you us an idea of the wide variety of devices that are out there made, that are running Android, and then specifically, how many of them are Samsung devices. So let's talk about the specific versions, different versions of Android. Android versions are defined 3 ways. There's the code name, the version, and the API level. Those don't always line up evenly, so you'll sometimes see it referred to one way or the other way, but you need to know how they line up. This is the distribution as of October 26th for each different version of Android. October 26th is a while ago, but the page I pull this from at developer.android has not been updated since the 26th because the feed they're pulling data from is under maintenance. So expect it to be up there soon. Probably the biggest change you'll see is currently Android Pie is undefined, doesn't have any data for that. Once that updates, I suspect that we'll have a bit of data there. Now, it's important to understand this and to check out that page so you can understand what versions of Android are popular. This is based on people visiting the Google Play Store and what version of Android they're running on their device. So we can see that 88.9% of the devices visiting Google Play Store are running between Android version 5 and 8.1, Lollipop through Oreo. The other categories got Kit Kat. Most of it's Kit Kat. There's Jelly Bean, Ice Cream Sandwich, and Gingerbread in there. Not shown are Honeycomb, Froyo, Eclair, Donut, and Cupcake. Those are all end-of-life versions, and actually they just announced Ice Cream Sandwich is end-of-life as well, or sunsetted. So Gingerbread, Ice Cream Sandwich are both sunsetted, even though they're in that pie chart up there on the right. So what's new in Android? First, let's take a look at the short history of RAD Studio support for Android. It started out in XE5 in 2013 with Android support. It supported Gingerbread through Kit Kat. Honeycomb wasn't supported because it was only available on a certain tablets. It was a very short-lived version. Pretty much once Ice Cream Sandwich came out, Honeycomb kind of faded away. It was kind of an interim release. It was kind of a weird duck. Anyway, XE8 changed that. It dropped Gingerbread and only supported Ice Cream Sandwich through Lollipop. And then we kind of just kept adding new versions of Android. Tokyo dropped Ice Cream Sandwich. 2018, we released the Community Edition based on Tokyo that gave you a free tool for developing Android applications, actually all the platforms with Delphi and C++ Builder, Community Edition. And then in 10.3, just last year here in 2018, we updated both Community Edition and Delphi, C++ Builder, and RAD Studio in general for Rio. Now, this is a big change in our Android support, which we'll talk about more in a little bit. First of all, we dropped Kit Kat and Jelly Bean. So it has to be Lollipop or newer to work with Rio. We also added Android Pie support, the most recent version. Now, the reason for this is the Google Play Store, actually the Google Play Console, which is where you load your app into the Google Play Store, has a new requirement. As of August of 2018, apps were required to target API level 26, Android version 8 or higher. And then in November, if you're updating, so new apps were required in August. In November, when you're updating, you had to target API level 26. If you run an app on Android Pie, you'll get a warning if it does not target API level 26. That's the warning will look like there, letting you know that the user knows they need to contact you, the developer, to get an update. Now, they're doing this because of a new permission model that was added, and which we'll talk about up here in a second. Also, the most recent version adds a lot of performance and security improvements as well. And going forward, they're going to keep incrementing this target API version, target SDK version each year, requiring new versions. So the new runtime permission model was introduced in Android 6.0 API 23 Marshmallow. You can use the support library to target earlier versions. So for example, if you wanted to target Lollipop, which Rio supports Lollipop, the Android support library is built into RAD Studio, Delphi, and C++ Builder, takes advantage of that, so that you can still support Lollipop with the new Android runtime permission model. Now, the support library doesn't go all the way back to Android 1, which is why it doesn't support every earlier version. It only supports Lollipop moving forward. But the new permission model streamlines auto-update process and gives the user more granular control over the permissions. So instead of prompting the user for all the permissions your application may or may not use at startup, the user is prompted each time the permission is needed. The user can also allow or deny individual permissions. So this is what the old permission experience looks like when the user updates it and there's a new permission required, or when they're installing the application, they'll get a list of permissions and they can accept all those permissions. So the permissions were published in the manifest, and when you installed it or updated it, you just were presented with that list of permissions. Now, the first time the application requests the permission, an individual permission, the user has the option to deny or allow it. If they deny it once, the next time they have a checkbox that says never ask me again. So it's important that you as a developer ask your users at the right time and in the right way so they're more likely to hit allow. Otherwise, they could deny a permission that's needed in your application and have a poor experience because the application cannot do what they want it to do because they didn't understand why it needed that permission. We'll talk about the timing and strategy for that in a little bit. So this is an example of how the users have this greater granular control where they can disable individual permissions for their application. So we see there's two ways you can get at it, really. You can go to app permissions and see all the different permissions and which apps have requested it. So we see shopping, requested location, Amazon shopping, but I didn't give it to it. Whereas the camera requested location and does have it. Okay. You can also go into an application and go into its permissions. So we're going to Chrome applications individually and see what permissions it's requested and which permissions have been granted to it. And you can come in and change these. It's important you understand this because a user may give your app that you created permission and then later change it. Permissions are broken into two categories, dangerous versus normal. Normal permissions are things like internet access, vibrate, Bluetooth, etc. Used to be long ago with the old permission model, every app needed internet permission and every app popped up when you installed it and said, hey, this needs access to the internet. Anymore, that's considered normal and no longer prompted for that. But then the dangerous permissions are the ones that users get prompted for. Now, dangerous permissions either involve privacy or potential cost. So, for example, sending SMS may have a charge attached to it with your carrier, so they want to get your permission, or the user's permission, before the app is able to send an SMS message. One note, though, is that the permissions are grouped. So if you request send an SMS message, then you also, and the user allows that, then the user also allowed receive SMS message because they're both in the same group. And as I mentioned, you still have to put all the permissions in the manifest as well, even though you're asking for them individually. Okay, let's take a look at what's new in RAD Studio with its new API level 26 support. But first, to understand what the significance of this is, you really need to understand how the app manifest, what it is, the Android manifest, and how it works. I guess the technical term is Android manifest, but I tend to refer to it as app manifest. And what it is, it's an XML document that describes to Android OS how to interact with the app. One of the things it does is it tells the OS and the Play Store what versions of the Android SDK it supports and requires. It does this through the uses permission tag. Now, there's two properties in here, min SDK version and target SDK version. Min SDK version is the version of Android required, the absolute minimum required for this application to work. By default, Delphi C++ Builder RAD Studio puts 19 in there, which is Lollipop. The target SDK version is the version of the SDK that was used to build your application, which we use 26 for Oreo. Now, what this version means, the target SDK version, is it means that's what was used to build the application. So if you're running on a device with a newer version of Android, then it knows to put compatibility mode back to that version. So if you're running on Android Pie, it says, whoa, Pie is after Oreo, so therefore we're going to provide compatibility as for an Oreo-based application. So there's no maximum version. Actually, there's a property for maximum, but they say don't use it because it doesn't really do anything. Just as an aside. Also, though, there is a lot of other stuff that is in the manifest. So, for example, all the permissions are listed there as users permission, package name, version, app label, any activities. By default, Delphi C++ Builder typically just have single activity applications, but you can have multiple activities. If you have intents that you are receiving, that's in there. Intents are a way to send messages between applications. Also, if you're doing a broadcast receiver, that's in there. The fact if your app is compatible with keyboard, different orientations, etc. There's a lot of useful information that's in there. Now, the IDE manages a lot of this for you. It does this. The first time you build it for Android, it's going to create a Android manifest.template.xml file. Now, and then you can modify that, and then it will then build that into the actual Android manifest.xml, which is in the Android output folder, and bundle it into the application. Runs through all the tools to compile down. It's important that you understand this, because understanding how this works can give you the ability to be a lot more flexible with your application and really go beyond the regular applications. So I highly recommend you take a look at that link down there, learn to understand it, look at the XML file, and you can get a lot done there. New in 10.3 Rio is the new Marshmallow Android API 23 permission model, but we're using Oreo API 26 to build. So we've moved way forward. I can't remember what version I was using before, but I was using a very old version. Now we're using Oreo. So that means a lot of changes throughout the library because it's using the new version, the target SDK version. The Android permission architecture is redesigned to support the new permission model. Also, the Android manifest has been updated with the new information because we are targeting a new SDK. We also switched to a new version of the NDK. When it was released, it was the most recent version, NDK 17B. 17C came out like immediately after or during the beta process. And then 18 came out. So a future update, we may end up seeing, we'll probably see it move to version 18. Again, the NDK version is something that didn't change really since 2013 when Android support first shipped in RAD Studio. So we see this big jump forward, both in NDK and SDK versions. Also, platform controls and Z-order behavior. We now have a huge step forward here in this area. This is a big deal. Great to see. I'll talk about more on that in a little bit. And support for Unicode emojis, which is exciting, I suppose. Actually, it is. Unicode emojis are a big deal. So it supports Android versions 5 through 9, which is 88.9% of Android devices, or more, probably at this point. So I'll break this down again. This is the chart we saw earlier. Again, pointing out that 5 through 9 is supported by FireMonkey, which is over 88.9% of devices. Again, this is data from October. Gingerbread, ice cream sandwich, and earlier are not supported. Again, like I said, Jelly Bean and Kit Kat are only two that have not been sunsetted, end of life yet, but they are very, very small portion of the market. Now, when you're submitting your app through the Google Play Console, it's going to tell you how many devices, different devices, your app can run on. And it's going to say you can't run on quite a few different devices because it's all the devices that are running KitKat or newer. But that's different number of devices. That is not active devices. So 88.9%, more than 88.9% of active devices are supported by Rio, whereas there are a lot of different types of devices that are out there that are no longer supported, but nobody's using them or very few people are using them. That's an important differentiation to understand. So let's break down the new Android permission model. This is how you're going to ask for permissions. So you're still going to have the permission list in your manifest, which you define through the project properties. But before you can use it, you have to ask for it. So here is the location sample, which ships with Delphi. And when the location sensor switch is activated, if it's checked, then if we're on Android, we're going to do this specific code. And so we also have up here in our uses, we have these ones that we're using specifically for Android. So right here is where we're going to request the permission. So the permission service, request permission, and then the name of the permission we want, which is defined here in this manifest permission class. And then we pass in a anonymous method. It could also be an event handler that is called once this user accepts or allows or denies the permission. So in here, we're going to have an array of permissions and results. So probably here you should check to see, I guess we know that we only asked for one permission. But if you ask for more than one permission, then you could go through and check for each one individually to see which permission was allowed and which permission was denied. In this case, if we have one, because we only asked for one, we check it, and if it's allowed, then we turn on the location sensor. If it was denied, then we uncheck the checkbox, the switch, turn the switch off. Okay. Now, if it's not on Android, then we just turn on the location sensor, set it to active, and if the location sensor switch box was turned off, then we just turn the location sensor off. And then here's the same code in C++. Same process you're going through, just with C++ instead of with Delphi. So let's take a look at some of the library for the permissions service that you're going to take advantage of. This is all in the system.permissions unit or namespace. Is permission granted? You're going to pass in a name of a permission, and it's going to tell you yes or no if the permission is granted. Again, you don't want to assume it's still granted. This tells you if it's currently granted. Now, the user may have switched out of the app, ungranted the permission, right, and then gone back into your app again, or, there are a number of scenarios. So don't ever assume it's granted. Now, in one process, right, you check to see if it's going to be used, and then you use it, right? You don't need to, say, oh my goodness, 1 millisecond has passed, I should check again. No, you don't need to do that, right? But don't assume, right, between scenarios, right? So if the user presses a button and goes to a new screen, and you checked when the user pressed the button, and then on the new screen, you go to use the permission again when they press another button, check it again, okay? So every time the user interacts with it, you want to check the permission again. Is every permission granted allows you to pass in an array of permissions, and it will tell you if all of those permissions are granted. Okay. There's a list, shows you where you can find the permission strings. I mentioned that earlier, just so you know where that, and then also descriptions. Request permissions method. This is the method you use to request the permission. Now, you pass in an array of permissions, and then you also pass in either an event or a anonymous method that you get called when it's granted. You can also optionally pass in either event handler or anonymous method to display a rationale. Okay, so a rationale lets you display to the user why you need that permission. So we'll talk a little bit more about why you would do that later, but that can be useful. Just know that's a possibility that you can use to prompt the user for why you need a specific permission. This is the permissions result event handler or store procedure, or I'm sorry, not store procedure, anonymous method. You're given back an array of permissions, the names of the permissions that you asked for, and then the results of each one individually. So now let's talk about when and how to ask for permissions. You're going to want to divide the permissions you need up into these 4 categories. Okay, so permissions either critical, meaning you have to have it for your application to work, or secondary, meaning it's something that you might optionally, or the user might optionally do with your application, and it needs a permission for that. So, for example, if you have an application that's all about taking photos, you're going to need that camera app permission. That's critical. But maybe you don't. Maybe your application occasionally might take a photo, right? So it's a note-taking app, and occasionally you might want to attach a note to, or a photo to that note. Okay, that would be the photo permission would be a secondary permission in that situation, because the user might use that app forever and never take a photo, so you don't need to ask them for that permission right away. Clear versus unclear. Let's go back to the photo app, right? So you make a photo app. It's clear you're going to need that camera permission because that's what you're doing, but maybe it's not clear why you need a contacts permission, right? Why do you need a contacts permission? You're a photo app. Well, it's for sharing photos. Okay, that's the difference between clear and unclear. So if it's critical, you're going to want to ask when it first launches, right? So you can't do anything with this app without these permissions. Those are critical permissions. Now, if it's clear, like the photo app or an SMS app, then right, just ask, right? I installed, fabulous photo taker. I need camera permission. Of course, because you're a photo app. Boom, give it to it. If it's unclear, then you want to tell the user, educate them why you need it. Okay, so this could be an onboarding, a series of onboarding screens that walks them through, hey, welcome to Fabulous Photo App. We also need location permission for this reason, right? And explain why you need it and then ask them for it. Now, if it's secondary, if it's something that they can use the app without ever encountering the permission, you're going to wait. And as soon as they go to use it, then you're going to ask, okay? So we'll go back to the note-taking app, and you're like, hey, I want to attach a photo. So they tap that camera button, and it pops up and says, hey, I need camera permission. In their mind, well, I tapped a button with a picture of a camera because I wanted to take a picture. So, of course, this app now needs camera permission. That's clear to me. They'll allow it. Okay. It might be unclear why they need it, because it could be that they're going into a screen to collaborate or share something, and you need contact information, and they might not realize that this needs contact information. It doesn't make any sense to them. So you're going to want to provide information. You're going to educate them to why you need it. Maybe it's a dialogue. It could be the rationale, whatever, telling them why you need that permission. So by delaying these secondary permissions, you don't bombard them with all these requests at once. I've had experiences where I've installed apps that have done that, where it's just like, I need this permission, this permission, this permission. First permission, okay, sure. Second permission, grumble. Okay, sure. Third permission, I deny it. I don't care what it is. If you ask me for 3 permissions in a row, I'm getting frustrated. Fourth permission, I uninstall the app. Okay? So think about that with your users. You don't want to bombard them with a whole bunch of permissions all at once. You want to either educate them or only ask them when you need them. So now let's talk about Z-Order and native controls. Android Z-Order and the native controls. When I heard about this, it sounded to me like a movie title, like World War Z, Apocalypse. I don't know. It's crazy. So I made this cool graphic up about the battle between the androids. So what is Z-Order? Z-Order is stacking controls. X and Y is position, horizontal or vertical on the form of a control. But if you have multiple controls overlapping, that's Z-Order. So the control that's in front has a higher Z-Order than the control that's behind it. Now, where this is a big deal is the platform native controls. So the map view, media player, web browser. When you put in earlier versions of Delphi, when you put a non-native control over a native control, on the designer, it would appear like the button is in front of the media player. But then when you run it, the media player pops in front. And this is because of the way that the native controls, the platform controls, were painted on top of, or added on top of, the FireMonkey form. With Rio, this is now fixed. Okay, first of all, the always platform native controls, those four you see there, now use material design theme. Okay, so they have a more updated look and feel. The list of controls there you see in this next group here, when you set the control type to platform, they understand and respect the Z order. Okay, so that means you can put a speed button over the media player and it will stay with the media player at runtime. Now these controls here, the calendar, the T-edit, the switch, and the multi-view, when you set them to platform controls, they become actual Android controls. So let's talk about the edit for a second. The edit control previously, or when it's a styled control, is a box that the user can tap into, and the keyboard can appear, and they can type on the keyboard, and text will appear in there, and they can select text, and they can cut it and paste it and stuff like that, just like you would expect an edit control to do. But when you set it to platform, instead of FireMonkey rendering that behavior and the copy and paste and the caret position and the selection and stuff like that, instead it's done by Android. Okay, so there's going to be some subtle differences there, most notably around spell checking, right? If you're running a keyboard that has a spell checker, then that will work now in that edit control. Let's say you have some sort of app installed that when you select text gives you an extra option in that edit dialog, or edit little thing that pops up there where you copy and paste. And for example, it lets you search it in your favorite browser, for example. That will be there because it is now a platform native control. Okay, so having platform native edit controls could really enhance your user's experience if it's someplace they're doing a lot of editing text in there. So how do you do this? Your controls have a control type, your controls have a property called control type now that you just set to platform instead of styled. It's available in the object inspector, or you can do it in code. When you set calendar, edit, switch, or multi-view to platform, it becomes a platform native control. The other ones that were listed just become Z-order aware to other platform native controls. This functionality was all previously available in Windows and iOS, and now it's available on Android. So, I kind of talked about Samsung a couple times in here. You might be wondering why, if it wasn't clear already. So, almost half of all Android devices are by Samsung. There are more Samsung Android phones than iOS phones. Okay, so if you take all the iOS phones that Apple makes, Samsung makes more Android phones. Okay, that's a pretty big deal in my mind. Many of the Android features that are now standard started out as Samsung-specific features. So Samsung was one of the first, I don't know if it was the first one, but one of the first ones to offer the multi-window mode that's now standard on Android, where you can have multiple apps visible at the same time. Samsung was a founding member alongside Google with the Open Handset Alliance, which is the organization that drives Android. So we think of Android as being a Google platform, and Google is a big part of it for sure, and the Play Store, all the Play services are services of Google, but the Android OS is also driven by Samsung. Okay, so if you go to the androidreview.googlesource.com URL you see there, you can see all the commits, merged commits by Samsung or related to Samsung products, and there's a lot. I couldn't find any place I could find a really statistics about how many are Samsung versus other manufacturers, but there were quite a few, and I looked at a few other manufacturers, and it seemed like Samsung had more. I could be wrong. Like I said, I didn't get all the details, but Samsung is involved in the development of Android. Plus, Samsung phones still have a headphone jack. I don't know why no one else is doing this. I was using Pixel for a while, and Pixel 2, they took the headphone jack away. I'm like, that's it. I'm using Samsung now. And so now I have a Note 8 and then just upgraded to a Note 9. Now, I hear a lot of developers that say, I will get a Pixel because Pixels are updated to the latest Android release, and that way I know I can always test the latest version of Android. Now, that's great. You know, you want to support, test the new Android features, plus it's new and exciting. But as we saw, Samsung is the predominant market or smartphone manufacturer. So your users aren't using Pixels for most likely. They're most likely using a Samsung device. So you should be testing on a Samsung device, whether it is the most popular Samsung device or one of the more popular Samsung devices or just a Samsung device in general. Samsung does offer a service where you can test online, although I understand it's not always easy to get the device you want to test on. So just something to be aware of. So here's a chart showing smartphone market share by manufacturer. We can see that Apple back in 2017 Q4 actually jumped up ahead of Samsung, but for the most part, Samsung has been ahead of Apple. And now Huawei is producing more smartphones than Apple as well. So, yeah, Samsung is producing all the most of the Android devices, and the next three most popular ones are Chinese companies. So, which currently are really only used in China. I guess Russia's using quite a few of them too, but you don't see them much outside of Asia, I believe. I could be wrong on that, but they're not in the U.S. very popular. There's a lot of trade wars going on around that, but that's another webinar. The other thing about Samsung, DeX. DeX is Samsung's desktop experience. It allows a Samsung Note to enter a desktop mode where you can have an external display, keyboard, mouse, a physical Ethernet cable, etc. It makes it behave like a desktop OS, meaning multiple windows opened, multi-window mode, and such. I know people that this is what they do. They have one device, a Note, that they use for their mobile and their desktop both. You can edit your manifest and get the basic DeX functionality going pretty quickly on your existing Delphi applications. This is kind of an ongoing research project for me, so you can stay tuned for more information at delphi.org. But Samsung's official guide is down there at the bottom to tell you what you need to do to enable DeX mode. Raspberry Pi. How many of you are waiting for this part? Android Things was announced at Google I/O 2015. And it's an Android-based embedded operating system for IoT devices. When they announced it, they said, hey, we're just taking some of these parts out of Android and making this Android Things. And I'm like, oh, none of the stuff they're taking out, stuff that Delphi or C++ Builder requires, so therefore it should work with Delphi or C++ Builder. Well, they have a platform going there where you can go out and check it out and download it, install it onto two different developer devices, the Raspberry Pi 3 or the NXP, whatever device it is there. Raspberry Pi 3's cheaper or more affordable, but not quite as powerful as the NXP one. The NXP one's more expensive, but more powerful. The process for doing it is you need to download Android Things Setup Utility, which you need a free Google account to do that. And then you can use it to create an SD card. Just use a generic image, is what I did. And then use that SD card, boot up the Raspberry Pi 3, and then easiest thing to do is connect a screen to HDMI cable and see what the IP address is. It's going to pop up and display the IP address, and then that's what you need to connect to it. If you don't have a screen to connect to it, you can look at your router or some other way to find out what its IP address is. And then once you have the IP address, you're going to go into Windows, Command Prompt, and type ADB connect, and then the IP address. And then in RAD Studio, it will see the Raspberry Pi 3, and you can deploy to it like you can any other Android device. Now, keep in mind, you don't have a touchscreen, okay? And you're going to want to just be more cognizant of it's a different platform, different form factor. If you're using Raspberry Pi 3, it's not as powerful as the other Android devices you're used to developing on, so you're going to be probably doing some sort of device that isn't interacting with the user quite a bit and is just doing something and running in the background, collecting information, for example. So, yes, you can run Delphi applications on Raspberry Pi with Android things. So in conclusion, Android is the largest and possibly most important platform. Largest is a fact. Most important, possibly an opinion. Definitely important, though. You can't deny that. 10.3 Rio is the biggest Android upgrade since XE5. That is a fact. More has changed in Rio, specific to Android, than since XE5 came out and Android was introduced. So much has changed. Keep that in mind, though, that the new permission model from that's required by the Google Play Store, the Google Play Console, requires that you add new code. If you don't, it won't work. Okay? So make sure you go in there and adding the code to support those permissions. The new Z-order support gives you additional flexibility in your Android applications. Doesn't require that you do anything. You don't have to if you don't want to. But if you want to, and I suggest you do, it does give you more flexibility. And then also, Samsung is a major part of the Android platform. I'm a big Android fan, bit of a Samsung fan as well, but I'm not mentioning Samsung because I'm a fan. I'm mentioning it because it is important and that you need to be aware of that. Lastly, Android is more than just smartphones. It's Raspberry Pi, it's Chrome OS, it's DeX, it's a lot more. And now it's time for Q&A. If you have questions, put them in the question panel there on the right, and I'll do my best to be answered for you. If you're watching the replay, go out there to Delphi.org, the URL you see there at the bottom, and you can find the slides, and also leave comments there, and I'll most likely be able to answer them for you, or somebody else possibly can. This is Jim from the future now. Unfortunately, the Q&A recording did not work. I'm not sure why. It just came back as garbage, not even the audio. So I've published the Q&A log below, and I've gone back through and added answers, typed out answers to all the questions that were there, and elaborated on things and added links. I'm going to go ahead and take a moment to share some thoughts on some additional points that came up and some things that I had cut out of my presentation for time. So I'll go ahead and add those here to the video. But make sure you go out there to the link you see, delphi.org/2019/02. Get the most out of Android with 10.3 Rio to get the full Q&A log. I will put these links or these statistics in detail in the blog post as well, but I wanted to share some of these here. 85% of the global operating system market is Android. That's pretty amazing in my mind, especially when we consider that almost half of those are Samsung. From a different source down at the bottom, you see 34% of the US smartphones are by Samsung. So 34% of smartphones are made by Samsung running Android. Pretty significant chunk there, and that's why I think it's worthwhile paying attention to Android as well as Samsung. 62% in the US is Android. It's more in China and a lot less in enterprise markets. I was looking for an updated statistic on this. I couldn't find anything. I would expect that to be higher, but then again, it might be a matter of people are willing to pay more for devices in the enterprise, perhaps. Anyway, also there, I talked a little bit about Android diversity in my presentation, and there's a number there. 400 different manufacturers make Android devices, which is crazy. There's over 4,000 devices, and that's from a few years ago. It's way more now. And over 600 devices were launched in 2015 alone. So I know that number is more than it is now, but if 600 were launched in 2015 alone. So there's a lot of different Android devices out there. So it's a bit of a daunting task. In the question log, I did comment that as far as testing, you really want to test as many devices as you can and as many platforms as you can. But I realize that's not realistic. So if probably the recommendation I would make is to test on Marshmallow being the minimum SDK version, Oreo 8.1 being the target SDK version, and then probably, if you can as well, on Pi being the most recent version. Then also look at the dashboard, version distribution dashboard, which there's a link to, that will tell you what versions are most popular, and test on those as well. So I think right now Nougat is the most popular version. So test on a Nougat device, and then you can look and see at your user base or any place else, and so you can determine what specific device is most popular. So find out what device is most popular in the region or industry or whatever you're targeting, and test on that as well. So that's like 5 different devices you got to test on, I realize. Now, again, it really comes down to your comfort, right, and how complicated your app is. If your app's pretty simple and you're okay with users reporting bugs to you, then test on one device and put it out there. But again, depending on how comfortable you are with your users reporting your bugs, you might want to do more testing. Additionally, Samsung has a cloud service you can test on all their devices, and there are a number of other providers out there that provide a cloud service where you can test on devices. So those are options as well. It really depends on how comfortable you are with bugs being reported by your users. I didn't include this in there. This is showing the popularity of different versions. So we see, yep, I remember correctly, Nougat is the most popular version. This wasn't updated since October because they said there's something wrong with their stream, which seems really weird to me. But probably still the case that Nougat is most popular. Oreo maybe is supplanted at this point just because it's a newer version. Then Pi, they still don't have data on Pi published. Not sure why. So, yeah, I would be checking on Pi, Oreo, Nougat, and Marshmallow just to make sure you're getting the maximum coverage. Actually, Lollipop. I'm sorry, Lollipop is the oldest version with support on. So I would touch on Lollipop, and that's actually really important because the permission model was introduced in Marshmallow, but because we use the support library, it supports all the way back to Lollipop. So I would test on Lollipop, Oreo 8.1, Nougat because it's target SDK version, and then possibly Pi because it's the newest platform. This is a chart. I pulled it off Wikipedia. It comes from the Android developer dashboard, but they archived the version history information. So you can see it goes all the way back to 2009, and then they have updates here since October. So I'm not sure where they're pulling the updates from because Google has not updated. So here it says no data, October. Oh, wait, that's 2016. Yeah, so right here is where that would be, that it chopped off. So it might be this hasn't been updated since there. Oh, this is February 2018. So they haven't updated this since February 2018. Wow, that's really old. It helps if you read things. So this just shows the progression of different versions when they're introduced as they gain popularity. So introduced here with 0% market share, and then over time that goes up and then gets less again. So this is cumulative, right? So we see here, for example, that blue, this would be what, gingerbread, has roughly 10% of the market here, where here at this time period it has, the majority of the market. So right now we can see it, or in February 2018, so a year ago, we see that this was a fairly even split between Lollipop, Marshmallow, and Nougat. Okay. Neon instructions. This came up during the Q&A, and I answered it. I did have slides about this as well. Neon instructions, everybody brings up, hey, what about neon instructions? How does that impact what device I'm using for testing? So when RAD Studio support was introduced in XE5, part of the requirement was the device has to have neon instructions. What are neon instructions? So first of all, ARM is a standard. Anybody can build an ARM processor, Samsung, Qualcomm, Apple, etc. They all built the Snapdragon, very popular one. What's the other one? Apexion? I can't remember the other one. I should remember it, but I don't. There's a number of large manufacturers, including Samsung and Apple. Neon instructions are what's called an advanced SMID extension. Then they provide a media processing engine like MP3 decoding. So what that does is allows a processor, a lower powered processor, to accomplish media processing tasks, which are typically very process intensive, more efficiently using less power. That's a great thing. So originally, Neon instructions were optional. They were really all over missing from the NVIDIA Tegra processors and maybe some other really low-end processors that were out there. Tegra was pretty popular for a while, but ended up dying out. It was a low-priced alternative processor based on ARM. Now, in modern ARM processors, Neon is required. So this is similar to MMX instructions. If you remember back in the day, the Intel had this big marketing thing about MMX instructions and make sure you get a processor with MMX. And MMX were a multimedia instruction set that were added to the x86 processor instructions. It started out as optional. It was something you could get an upgraded MMX-powered computer, had a little sticker on the bezel. But now, all desktop CPUs, both Intel and AMD, include MMX instructions. Same thing with Neon, started out as optional. Now it's mandatory. This also came up, Intel Atom processors. These were short-lived. Intel introduced Atom processors, which were lower powered, lower price processor to be included in mobile devices. They were in Android for a little while. Google and Intel kind of partnered, made a big deal about it. And then in 4.4 KitKat, they added Houdini. Now, the reason this is a big deal is the Atom processors x86 based, while its ARM processors are ARM based. They're not x86. It's a whole different standard. So, Google added libhoudini to provide ARM compatibility. And the reason they had to provide ARM compatibility is because of games. I think the number is like 75% of all the apps in the marketplace are games. That's where all the money is. People spend a lot of money on games. We think of our devices as productivity devices, but they're not. They're game devices. Pretty much every game out there include native NDK parts. So you have to have libhoudini to run any games on an x86 based Android device, especially because the Android Atom processors had such a small market share. They were very much a niche. Intel in 2016 decided to discontinue it, so it went from being a niche to being discontinued. Small little blip on the radar. Historically speaking, though, we tested it. I have a Atom-based device that I got and tested it. Worked fine with the Delphi application, C++ builder application. There were a couple bugs because it's slightly different behavior, and they actually fixed those in R&D. I can't remember what version that was, and they fixed those, and we were looking at doing more to try and serve it better, but then Intel discontinued it. And so, like I said, it went from being a small blip to being discontinued. Tizen. Tizen is Samsung's OS that they've developed that is it's a Linux-based OS backed by the Linux Foundation, but Samsung's the primary force behind it. They're using it in watches and smartphones. Smartwatches and cameras and some smartphones. They have a Z series of phones that runs it. I think it's only in China that they're selling it. It was conceived as an HTML5-based mobile OS. Now, in my opinion, I'll give you a little history. Back in the day, I used to work for a large PC manufacturer, fairly large one. And it was common knowledge that PC manufacturers would occasionally ship an AMD-powered computer and would tell Intel that they were seriously considering switching to AMD and it was being done as a marketing thing, a bargaining technique. Because if Intel feels like they have the power, we can charge you whatever we want to for our processors because where else are you going to get them? Then they have a monopoly, they can raise the price. But if the PC manufacturers feel like they have the power, we can ship any processor we want to. AMD, yours, I don't know, we'll make our own. Then the PC manufacturer has more power. And so it's all marketing. Now, AMD processors are fantastic processors. I've owned a few of them over the years. I'm looking at buying one now. So I'm not trying to discount AMD, nor am I trying to discount Tizen. I'm sure it's a fantastic OS as well. But in my opinion, Samsung is mostly using Tizen as a positioning thing, right? So they're trying to say, hey, Google, we are not tied to you. Now, Android is open source, but Google adds in the Play services, which adds quite a bit as well. So Samsung maintains their own app store on Android, and Tizen gives them a way out. So it could be for negotiations with Google. It could just be that they don't want to put all their eggs in one basket, right? So if something happens where they can't use Samsung anymore, or I'm sorry, if they can't use Android anymore, Tizen is an alternative. But they're not going to abandon it anytime in the near future unless they have to, because abandoning Android compatibility and the ecosystem would be really dangerous and risky on their part. Well, the reason Android devices are so popular is because there's a large app store. So again, that's my opinion there, but I don't suspect we're going to see Samsung switch wholesale to Tizen anytime in the near future unless something significant happens to Android. Also worth mentioning is Fuchsia. So Fuchsia is Google's new mobile OS. So Google's developing it. Unlike Android and Chrome OS, which are based on Linux kernel, it's based on a new kernel called Zycron, which is a microkernel. And this is something they're developing for a while. Just recently, in 2019, it was confirmed that Android app support has been added to the code base. So you can run any Android apps on a Fuchsia device. Again, time for my opinion. This is possibly a unified successor to Android and Chrome OS. So right now, Google's shipping both Android and Chrome OS. There's a lot of crossover in there. They recently added Android support to Chrome OS, but they're two different operating systems, both based on Linux. So this could be that they're trying to come up with a unified replacement successor for those. Although Google's known for developing and then killing off many experimental projects. They frequently will release two different messaging apps, for example, and you're like, oh, which one should I use? And they're like, use whatever you want. And then later they'll say, oh, and we've decided to end of life this one because it didn't catch on. It's frustrating, but that's what Google does, a lot of. It also could be driven by the fact that they have been in this big lawsuit with Oracle over the use of the Java headers, which was settled, unfortunately, not in Google's favor, but they've gone back to appeals, and I think it's going to the Supreme Court now in the United States. So lots of possibilities there, but the big takeaway is that Fuchsia is confirmed that it will have Android support. So if you have an Android app, it will run on Fuchsia. If Fuchsia takes off and replaces Android and is a big deal, I'm sure Embarcadero will look at supporting that as well. Now, it seemed like for the longest time, every time we talked about iPhone, iOS, or Android support, someone would say, what about Windows 10 Mobile or Windows Phone or Windows CE or whatever version flavor it was called at the time? Now, I've owned a number of these devices over the years. I really like them. I think they're great devices, great OS. The reality, though, is it never caught on, never had significant market share, and it lacked a lot of the major apps. Microsoft has officially announced that they're end-of-lifing it. It's now on support-only mode, and it will be on support-only mode through the end of 2019. Some devices actually have been end-of-lifed sooner. The most recent update, they just updated it January 9th, but they've announced no more updates. They're no longer shipping devices, haven't shipped devices in quite a while, and it's now end of life. Unfortunately, it just never had a significant market share. Microsoft is instead investing a lot in Android and also in supporting iOS and planning to reach mobile because they realize it's very important because we're in a multi-device world through Android and iOS. So I hope you've enjoyed this. Again, there's the link to the blog post down there at the bottom. You can go down there and read the entire Q&A if you'd like. And I appreciate your time. Thank you very much. Bye.